My dad asked me how to explain this.
He's been trying to make something that will absorb as much light as possible and measure it. Some basics. Light can be reflected, transmitted, and absorbed. Imagine these stick figures are particles of light, photons. Different things can happen to them when they travel to a surface. Reflection.
Transmission.
Absorption. Photons don't really scream.
Oh.
Things that are good at absorption are really black. No reflection, no transmission. Here are some images of things that are really black, as seen with an electron microscope. Gold black. Nickel phosphorus black. Black silicon. Another good way to make something appear black is to cover it with nanotubes. In fact, carbon nanotubes have the world record for being the world's blackest substance.
So my dad uses them. Nanotubes are really small.
How small?
Much smaller than a human hair. Louis XIV. Big hair.
Normal human hair. Carbon nanotube. A big carbon molecule that looks like. The nanotubes grow from a small bit of metal that is heated and surrounded by carbon.
The trick is to grow a turf of tubes on a detector.
You can guess what happens.
Yeehaw!
Side view of a forest of tubes. End views.
My dad puts the nanotubes on optical and infrared detectors. The detectors are like thermometers, sort of. This is a picture of a very black detector that my dad built. He thinks it's great.
The detector works like this. When the black coating absorbs light, the detector heats up and generates electric charge. What is the world's darkest detector good for anyway?
Measuring the temperature of the Earth.
Measuring the efficiency of solar cells.
Keeping your eyes safe at a laser light show. Yeehaw!